Hello everyone and welcome to this video. In this video, we're going to talk about rounding upper and lower bounds and finding the upper and lower bound in some questions. In this video, I want to show you the difference between questions because some questions you have to focus and you have to choose the right upper and lower bound to find the answer for the question. We will take two examples, two questions in this video. And by these two questions, you'll understand the idea of finding the upper and lower bounds of these questions, okay? So for question 9 here, a rectangular carpet measures 8 meters by 10 meters to the nearest meter, to the nearest meter. Now, first calculate the upper and lower bounds for the perimeter of the carpet, and then calculate the upper and lower bounds for the area of the carpet. First, we have to find the upper and lower bound of the measurements of the carpet. Here, let's say this is the carpet. Here, I'm going to put it in a table so you'll understand the idea more and how to choose between the right perimeter and the right area that gives you the upper and lower bound. So these measurements are the width and the length, okay? So this is the width and this is the length, like this. And this one is the length of the carpet. So if I want to find the upper and lower bound for these, I'm going to put them in a table like this. I'll show you how. Let's say this is the table. And this table gives me the upper and lower bound for the width and the length. So let's say this is the measurement for width and length and upper and lower, okay? Because we're going to use absolute error to find it. So let's say this is the upper bound and this one is the lower bound for the measurements of the width and length. So this one is the width, which is 8, and this one is the length, which is 10, like this. Okay. Let's see if it fits. Good. So the width is 8 and the length is 10. Focus on these steps because I want to show you the difference of steps in answering questions like this. Now, as we said, this is the width and this is the length. And we need to find the upper and lower bound using this degree of accuracy. So here we said to the nearest meter. And we made sure that this unit meter is the same as these units, which is meters. This means we can continue with the work without conversion of units. Now, we need a number from this because it's a unit, so we use the number 1. Now, we take the 1 and divide it by 2, as we always do, because we're trying to find two things, the upper and lower bound. When we divide them, we will get 0.5. So the degree of accuracy is to the nearest meter. So the absolute error will be what? Will be 0.5. Now, after finding the absolute error, I'm going to use it with the original numbers. I'm going to add it and subtract it from here to find the upper and lower bound. Add it and subtract it from here to find the upper and lower bound. So 0.5 plus 8 will give me the upper bound. So it's going to be 8.5. And to get the lower bound, I'm going to subtract it, 8 minus 0.5. So the lower bound will be 7.5. Same idea with the 10. I'm going to add it to find the upper bound. So it's going to be 10.5. And subtract it to get the lower bound, which is 9.5. So by using the method of the upper and lower bound, I got the measurements, the width, the upper bound of the width and the lower bound of the width, and the upper bound of the length and the lower bound of the length. Now I have the new measurements of the upper bound of the carpet and the lower bounds of the carpet. It means I can draw the carpet without any problems. So the small carpet and the big carpet like this. This will help me find the measurements that I want, okay? So here, let me take this here, this here. This carpet is the lower bound carpet, and this is the upper bound carpet because I have a big carpet and a small carpet here. The small one will be what by what? I'll take the lower bounds and put them here. So it's going to be 7.5, 7.5 by what? By 9.5. So 7.5 by 9.5, like this. This means this one is 7.5 and the other one is 9.5. I'll make space between them so you can see them. So this is the small carpet. I'm just explaining the idea with with these shapes, just to show you how it will look like. Okay, I'll put this carpet here so you don't get confused between the two carpets. So this one is 8.5 by 10.5. So this is 10.5, and this one is 8.5. Same idea, 10.5 and 8.5. Now, finding the upper and lower bounds means find the highest measurement and the lowest measurement. Now, if you want to do it from here, it's easy now. Now, I can find the lower bound of perimeter for question A by adding all of these together, and the upper bound of perimeter by adding all of these together. So when I add all of these together, let's use a calculator here. Let me show you how. So 7.5, I'm trying to find the lower bound of perimeters, okay? 7.5 plus 7.5 plus 9.5 plus 9.5. And the lower perimeter bound is 34. So here, I'm going to write it as an answer here. So we have the lower, the upper, find the upper and the lower. So I'm going to write them like this. Upper and then lower, okay? And lower bound, okay? And I'm going to write the answers under them for each one of them. I'll make it as a table so you don't get confused. For question A and question B together. So the top ones are A's and the lower ones are B's, like this, A and B. This question here, this question here. And separate them with a line like this. So I found the upper and lower. So the upper, I didn't find it yet. I found the lower perimeter, which is 34 meters, of course. Focus on this. Let's make it smaller. By adding the lower bound measurements like this, okay? And to find the upper bound perimeter, I'll add the upper bound measurements. So I'm going to take 10.5 plus 10.5, because I have two 10.5s, and 8.5 plus 8.5. And I will get 38. So the upper bound of perimeters is 38. So this one is 38. And this is the upper bound perimeter of, or the upper bound of the perimeter. So as we said, we found the upper bound of the perimeter, which is 38, and the lower bound of the perimeter, which is 34, by adding the lower bound lengths and or measurements and the upper bound measurements. Now, calculate the upper and lower bound for the area. It's easy. I come to the lower bound carpet and find the area, and then the upper bound carpet and find the area. Okay, I'm explaining here just so you know the answers for the questions, and then I'll talk about this. Okay, so how do you find the area? By multiplying width by length. So to find the area for the lower bound, you'll multiply the width by the length, which is 9.5. You'll multiply the width, this one, length by width. Same idea here, length by width, finding the area, okay? So the first one with the lower bound area, I'll multiply 9.5, 9.5 times 7.5 times 7.5, and I'll get the lower bound area, which is 1.25. So this one is 71.25, 71. So area equals 71.25. And this is the lower bound area. So the area here for the lower bound, 71.25, 71.25. Of course, meter squared, okay, meter squared. It's just I don't have space for this here. I'll write it here, meters power of 2. So you don't get confused between the questions. Same idea here. I'm going to find the upper bound of the area. I'm going to write meter square here. So you know it's an area. Same idea here. I'm going to find the upper bound of area by multiplying 10.5 times 8.5. I know this question is a little bit long, but you have to understand the ideas. So the maximum area is 89.25. 89 area equals 89.25, and same idea, meters squared. Meters squared. So by that, we found the upper bound for the area and the lower bound for the area. Let me put this here and write meter squared here so we don't get confused, okay? Meter squared. So the lower bound of the area is this one, and the upper bound area is this one. So this one is 89.25, 89.25, same idea, meters squared. So we found the upper bound of the area and the lower bound of the area by using these two carpets. As I said, we found the measurements. First, we found the absolute error. We said this is 1 after making sure that all the units are the same. We said this is 1. We divide by 2, we got the absolute error. We added and subtracted from each measurement to find the upper bound and the lower bound for each measurement. We drew the carpets, the lower bound carpet, let's call it the lower bound carpet, and the upper bound carpet. We found the perimeter from here and the area, and perimeter and area from here. We wrote them as upper bound perimeter, lower bound perimeter, upper bound area, and lower bound area. And that's the idea of this question. I hope you understood it. Now let me show you the table here. If you want to find a measurement from here, this is the upper bound, lower bound, lower bound. Perimeter, as we said, we add these together. Lower bound perimeter, width and length, you add them and you multiply them by 2. Same idea here, upper bound perimeter, you add these and multiply them by 2. When it comes to the area, you have to multiply. So multiplying here, you have the lower and the upper bound for the width. Which is smaller? Multiplying this number by this number or this number by this number? Very good. So multiplying the lower numbers will give you the lower bound area or the least area, the minimum area that you can get. And multiplying the bigger numbers will give you the greatest or the maximum area that you can get. So I want you to focus on this because it's very important in the next question. Now, after understanding this, let's move on to the next question. Here in the exam practice, we have question 5. Zach is in training for an athletics competition. He runs a distance of 200 meters measured to the nearest 10 meter. His time is 32 seconds measured to the nearest 5 seconds. Find the lower and upper bounds of his speed in meters per second. So basically, we are trying to find the highest or the maximum speed that he can get from these measurements and the least or the lowest speed that he can get from these measurements. So the first idea that we have to do is find the 200 meters upper and lower bound, and then the 32 seconds upper and lower bound using these measurements, okay, or using these accuracy or degree of accuracy. So I'm going to make it as a table like this so I can use it to find the speed. So first, I need to understand what am I dealing with and how to divide the numbers. So I have, focus on this. I have an upper and lower bound here. So I have an upper and lower bound. I'm going to write them on top. And I have two measurements. Two measurements. So upper and lower bound and two measurements. Okay. So here, let's see if the table is enough. Here, I'm going to do the upper bound. I'm going to make it bigger so we can see it in the answer. Focus on the steps and follow the right steps, okay? This is upper bound and this is lower bound, okay? So we have upper bound and lower bound. Now, here we will have the measurements. First, we will have the distance. Let's write distance so we don't forget. We will make it smaller so it fits. So this is the distance, and the distance is 200 meters, 200 meters. And then we will have what? We will have the time, and the time is in seconds, and we have 32 seconds, 32 seconds. Now, we have the numbers that we need to find the upper and lower bound for them. Now, first, let's take a look at the distance. The distance is has an accuracy or a degree of accuracy of 10 meters. This means to find the absolute error, I have to use the 10. After making sure that the units are the same, I'm going to use the 10 to find the degree of accuracy. So I'm going to say 10 divide by 2. As we said before, we always divide by 2 to find the absolute error. So I'm going to use the 10 divided by 2. First, let's put the line and make this bigger, okay? So we can see it, okay? So first thing we did, we divide the 10 by 2, and it will equal 5. And 5 is the absolute error of what? Of the distance. So we're going to use the 5 with the distance, add and subtract to find what? Very good, to find the upper and lower bound. Good job. So let's do this first, and then we will go to the second, okay? All the time. So first we have an absolute error of 5. So what do we do with the absolute error? Very good. We add it to the original to get the upper bound. So the upper bound will be, yes, 200 plus 5, which is what? 205. So the upper bound is 205 meters. 205 meters. Now the lower bound, same idea, but we're going to subtract the absolute error from the original. So 200 minus 5 will equal 195 meters. 195 meters. So we have the upper bound of the distance and the lower bound of the distance. Now we do the same with time. First thing we do, we have to find the absolute error. Now the time is 32 seconds, measured to the nearest 5 seconds. First, the units are the same. Now let's move on with the measurements. So to find the absolute error, we take the 5 divided by 2. Take the 5 divided by 2, like this. Okay? So 5 divide 2. Let's put it here. And the answer will give me the absolute error, which is 2.5. 2.5. Now let me write the absolute error here. So equals 2.5. I always like to write AE next to it to make sure that this is the absolute error and to make sure when I check or use it, I use the right number. Now I'm going to use it with time, add and subtract to find the upper and lower bound. So first, I'm going to add 2.5 to 32. 2.5 plus 32 will be 34.5 seconds. This is the time, or the upper bound of a time. And subtract it from here to get the lower bound. So 32 minus 2.5. Make sure you use a calculator to check your numbers. 32 minus 2.5 will give you 29.5. 29.5 seconds. And this is the lower bound of the time, the lower bound of the time. Now we have the upper bound of the distance and time, and we have the lower bound of distance and time. Now we come to the last part, which is what? Very good. Finding the upper and lower bound of the speed. Finding the upper and lower bound of the speed using these numbers. First, we need to know that speed equals what? Very good. Speed equals distance over time. Distance over time, like this. So to find the speed, we have to divide the distance by the time. That's why I told you in the other question, you have to focus on the numbers that you get. Now, the upper bound of speed will be the highest or the maximum number that we can get from dividing any distance on any time. So, how does the number become bigger? If the denominators become smaller, the number will become bigger and bigger. So, the numerator must be bigger and the denominator must be smaller. So, for example, if you divide 205, this 205 here, if you divide 205 over 34.5, you will get a smaller number than dividing 205 over 29.5 because the denominator must be the smallest and the numerator must be the biggest to get the biggest or the upper bound of speed. This means we divide 205 by 29.5 to get the biggest or the maximum speed. So 205 divide 29.5 like this. 29.5. And the answer I get is 6.95 with numbers. Of course, you have to round them to three significant figures. It's easier to write. So as I said, to get the maximum speed, let's write it like this, maximum or max speed that I can get from dividing a distance over time, I will choose the highest numerator and the lowest denominator. Again, to get the maximum speed, because I'm dividing, I have to choose the highest numerator and the lowest denominator so I can get the maximum speed. So here equals what? Equals 205 divide 29.5 like this, and focus on the reason that we did this because we need the maximum speed or the highest speed. So this will give me a number of, let me write at least four numbers, 6.949 like this. And then I'll round them to three significant figures. Meters per second, of course, meters per second. And they have to be written in three significant figures. So the answer will be what? 6.95. 6.95. And I rounded them to three significant figures, meters per second, okay? That's the first answer, which is the maximum speed or the upper bound of the speed. Now, the lowest speed, okay, or the minimum speed, let's call it minimum speed, or the lower bound of speed, same idea, same numbers. So, minimum speed, how can I get the minimum speed from dividing? Very good. The numerator should be the smallest, and the denominator should be the biggest. So focus on these steps. As we said, if I want the minimum speed, the numerator should be the smallest, and the denominator should be the biggest or the largest. So dividing these two numbers will give me the minimum or the lowest speed. I'll divide this by this, and I will get the lowest speed. So 195, I'll write it here, 195, divide 34.5, like this, 34.5. This will give me the least speed or the lowest speed or the minimum speed for this trainer or athlete. So here, 195, let me write the numbers from the calculator. 195 divide 34.5. And as I said, from the table, you should think about how to get the maximum or the highest number that they want and the lowest number by dividing a distance over time. You're not supposed to divide distance over distance or time over time. You're supposed to divide distance over time. To get the maximum number, divide the highest distance over the lowest time. If you want the minimum number, divide the least distance over the highest time. Now, 195 divided 34.5 will give you 5.652. So 5.652, same idea, meters per second. Now, when you round this to three significant figures, the answer will be 5.65 meters per second. And this is how you answer a question like this. Make sure that you got the right numbers. So, the lowest or the least or the minimum, which is the lower bound of speed, will be 5.65 meters per second. And the upper bound of speed or the maximum speed will be 6.95 meters per second. And this is how you answer a question like this. So focus on the difference of questions. Upper and lower bound questions need a lot of focusing. You need to focus on the table that you have and how to get the lower bound and upper bound of the measurement they want. Thank you very much for watching. See you next time.